Okay, so now that we know what isomorphic means, non-isomorphic means that they're different. So I want simple graphs, so that means no loops or parallel edges. So can't have any of those. It has 3 vertices. Okay, so it doesn't say anything about edges. So it could have no edge, it could have 1 edge, right? And if it has 3 vertices, I think it could have 2 edges or 3 edges, right? So those are all the different options. So if I've got 3 vertices, this would be a simple graph. And if I have 3 vertices, I could make an edge between 2 of them. So there's one, and there's another. I could make an edge between 2 of them. Or I could make an edge between all of them. And those are the only 4 that we would have with no loops and no parallel edges between 3 vertices. All right, so this one does not say simple. So it says no more than 2 edges. So I could have 0, 1, or 2 edges, right? And 3 vertices. So this is going to take a little longer, but it does start off with the simple case of just 3 vertices. Then I do have an edge between 2 of them, right? So that's another graph. Or I could do like I did above, right? Put an edge between 2 of the 2 different vertices. I could no more than 2 edges, so I can't have this one, right? So that's as many as I can do there. So it doesn't say simple, so I can make a loop and have an edge there, right? So that would be a graph. Or I could make a loop on one, a loop on another one, and just have the vertex here. And then I could have 2 vertices here and have parallel edges and then have that vertex off to the side. Or what else could I have? I could have 2 vertices and have, I don't know if you know this, you can have a double loop. So there's 2 edges and 3 vertices. Okay, so I could, I'm thinking of this one here, has a loop on one vertex, but I could just have these 2 vertices just kind of being there, not anything on them. And I think I might think of one more here. So here I've got a loop, here's an edge, so there's 2 edges, and then this off to the side. So I think that's all of the non-isomorphic graphs. So none of these can be matched up with other ones. All right, so simple, no loops, parallel edges, 4 vertices, doesn't say anything about the number of edges, does it? Okay, so let's start off with no edges. Whoops, and let's go to 1 edge. And then we can go to 2 edges, right? And then we can go to 3 edges. And then we can go to 4 edges, right? So some can be helpful to have kind of a method of what you're thinking of. So let's see, I could also have 3 edges like that. Or I could have 3 edges like that. And then thinking about 2 edges, this was one of them I had with 2 edges, but I could also have 2 edges like that, right? Trying to keep the graphs separate so you see them. All right, so then, let's think about it. What else could I do? I could have that. There we go, right? Goes out to that one. Or, the box. I could do the box and have 1 diagonal. Or I could do the box and have 2 diagonals. Or I could not close in the box. I think that's all I've got. All right, So this one's pretty challenging. I will not give you one this hard or this hard on the test. There won't be that many that if I ask you to do non-isomorphic. So here we go. 4 vertices and 3 edges. All right. So 4 vertices and 3 edges. Now do that. Then it doesn't say simple, right? So I'm going to do a loop and that. And then what else could I do? I'll keep up with the loopy thing and a vertex. And then, I'll do parallel edges between those two. And then I could, let me put bars in between them so we see the difference. So 3 edges. So if I make 4 vertices and I put loops on those, and then I could have that edge, and then I could put 2 loops on one vertex. And let's see, I could do this. Keep that off to the side. What else? I could play with more 2 loops on one vertex, so that, and then keep these 2 vertices by themselves. I could put 3 loops on one vertex and have the other 3 just kind of hanging out. I could put a loop here, and then I could do parallel edges to that vertex and another 2 vertices hanging out. And I could do 3 edges out to those vertices. And that makes me think, I haven't done regular triangle, have I? And have another vertex hanging there. Okay, let's go back to the loopy thing. Loopy, loop, and there we go. Then, let's see, 3 edges. Okay, so I could do 2 loops. I did 3 loops here. 2 loops and 1 loop, right? And then 2 isolated vertices. How about I do 2 parallel edges? I'm sorry, 3 parallel edges. So 1, 2, 3 edges between those 2 vertices. 1, 2, 3, right? If I did just 1 parallel edge, I could have just a edge between those 2. And I could have that. Wow, there's so many options, right? And then that and that. And I think this is my last one. Phew! All right, there we go.